Here are the solutions to the section 2.1 activity. The first question says, find the equation of the tangent line to f of x equals x minus 1 squared plus 1 at a equals 2. So we have to go back to the definition of the derivative that we just learned in the introduction to this section. We need to find that derivative at 2 as the slope of the tangent line, and we also need to find the point that the function goes through at an x value of 2. So I've written most of the solutions out here for you to save some time, but here in this first example, the key is we need to find f prime of 2 to represent the slope. That is the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h. So we evaluate the function. Everywhere we see an x, we put in a 2 plus h. Everywhere we see an x, we put in a 2 to get the two terms in the numerator. Do some algebra, we simplify. Our hope is to get rid of that h in the denominator, which we can do, and this simplifies to the limit as h approaches 0 of 2 plus h. We take that limit now, and the limit notation goes away, and that limit is just 2. And so that then is the slope of our tangent line. The point of the tangent line comes from evaluating the function at 2. We have an x value of 2. 2 minus 1 is 1, squared is 1, plus 1 is 2. So there's the point, and then that gives us this point slope form of the equation of the tangent line. Okay, the second example is similar, except here a is being played by 3 in our definition. So the derivative at 3 is the limit as h approaches 0 of f of 3 plus h minus f of 3 divided by h. We go ahead and evaluate the function at 3 plus h and 3, and again we have the 0 in the denominator, so our hope is to do some arithmetic to remove that 0. We were able to just do algebra on the first example. Here we need to be a little bit trickier, and this is one of the limits that we saw previously where we need to multiply by 1. So right here, multiply by 1 as the square root of 4 plus h plus 2 over the square root of 4 plus h plus 2. And after we do that multiplication and we simplify, we are left with this limit over here, the limit as h approaches 0 of 1 over the square root of 4 plus h plus 2. Now we can evaluate that limit, because when we plug in 0, there is no 0 in the denominator, and so that limit becomes 1/4. And that, again, that 1/4 is the derivative at 3, which is also the slope of our tangent line. And the point that tangent line goes through is the point 3, comma the output of the function at 3. Well, 3 plus 1 is 4, square root is 2. So there's the point, and then the point slope form, again, of the tangent line. Okay, in number 3, we have an object that's falling with position function given by 16t squared, where t is in seconds, and the output is in feet. The first question asks to find the average velocity from t equals 1 to t equals 3. Well, average velocity is the slope of the secant line between 1s of 1 and 3s of 3. So we can find out those points by evaluating the function, find the slope of that line, and we get 64 feet per second. The instantaneous velocity at 1, though, is the slope of the tangent line. So here we need the derivative, s prime at 1, and that's the limit as h approaches 0 of s of 1 plus h minus s of 1. This example works out similar to the first one above. We can just do some algebra to eliminate the h in the denominator. We can evaluate that limit and get 32 feet per second. Okay, the last question asks to find the instantaneous velocity generally at time t equals a. Okay, so that means we want to look at the slope of the seat. We can start with the limit as h approaches 0 of s of a plus h minus s of a, all divided by h. So basically here a is playing the role of 1 above, and this would be s prime of a that we are finding. Okay, so let's do the algebra to find that. We get the limit as h approaches 0. S of a plus h is 16 times a plus h squared. S of A is 16a squared, and that's all divided by h. Okay, so we press on with our algebra. This is the limit as h approaches 0 of 16 times. Multiply that out, we get an a squared, we get 2ah's, and we get an h squared, running out of iPad real estate here, minus 16a squared, all divided by h. Okay, we distribute the 16, we get the limit as h approaches 0. We get 16a squared minus 32ah, plus 32ah plus 16h squared minus 16a squared, all divided by h. Okay, so what happens then? Let's see, we get the limit as h approaches 0. 16a squared minus 16a squared, those two terms are gone. And then the other terms, we can get rid of one of the h's in each term. And we are left with the limit as h approaches 0 of 32a. Let's see, let's fix that since there's no quotient anymore. 32a plus 16h. And now we're in a spot where we can evaluate that limit by direct substitution. And we get 32a, and that would be feet per second. So now if we wanted to find the velocity at any time, all we would have to do is plug a, whatever that number is, 1, 2, 3, 4, into 32 times a, and we would get the velocity. All right, that's the solutions to the section 2.1 activity.